Hello and welcome to our webinar. It's all about building essential math skills for science. My name is Alison. I'm the Teacher Engagement Lead at Educate. I'm joined today by Karen Collins, who is PiXL's Head of Curriculum for Science Assessment and Research. She's also the author of numerous books about science education. She's going to discuss the challenges that students face when using maths in science and share her best practice for helping them succeed. We're also joined by Constance Young, who is the head of the editorial team at Educate. She knows Educate Science inside and out, and she's going to go over how we can help you support these skills with your students. So hopefully you'll leave this session with lots of tips to apply to your teaching practice. Before we get started, I just want to let you know about the Q&A feature of this webinar. You should see it at the bottom of your screen. If you have any questions for either Karen or Constance, please do type them into the box. We'll answer them at the end of the presentation, which will be in about half an hour's time. And without further ado, I'll hand over to Karen and Constance.
Thank you very much, Alison. And thanks everyone for joining us. We are just going to do a casual interview. We've got some questions for Karen specifically about the issues in maths for science, the broad picture, as well as some more concrete and specific examples and suggestions that she has. And then any questions you have, we're going to be really excited to get to those at the end of the session. So please feel free to send them on over while we're chatting, and Alison will help keep track of those for us. So I want to start out by just asking you, Karen, why should we be thinking about maths and science? What's the issue here?
Well, I think there's two different ways of looking at maths in science. I think it's one of the areas that we often neglect when we're teaching. We focus so much on the biology, the physics and the chemistry, that substantive knowledge, thinking about the topic areas. Quite often we forget that the Department for Education has actually given us a list of mathematical skills that need to be covered. And, for example, 30%, at least 30% of a physics paper needs to have a mathematical component. 20% of chemistry, 10% of biology. So that's the first factor, is it's part of the curriculum. The second thing is, if you look at the examiners' reports at both GCSE and A level, they cite continuously over the past 4 or 5 years issues with maths and science. Students struggling to convert units, interpret graphs, having problems with standard form, struggling to rearrange equations, struggling to even substitute into equations. And then it's not just a problem in science, actually. These same issues are coming up in geography, psychology, economics. So students are really struggling to translate their mathematical knowledge and understanding into other curriculum areas. So it's kind of coming from those two different angles. It's in the curriculum, we need to teach it. And students are struggling with that component within the maths curriculum as well.
Yeah, and there's a lot of marks up for grabs there, and it's even what we might think of as more foundational, simple skills that didn't make that cross-curricular jump.
Yeah. So it's really surprising actually, because if you think about something like, substituting into an equation, that's done a lot in algebra in maths, and students know how to do it. But when they're doing it, they're thinking about, X and Y. And then in science, we introduce lots of other letters, which can create a little bit of confusion. And I think a lot of the research shows that students really struggle with this transition between maths and sciences. And even a student who's really good at maths and really good at physics can struggle to translate and transfer that knowledge and understanding between the two. So even if they've got strengths in both, that transfer is still difficult.
And that's for your students who might be really strong.
Yeah.
But there's also students who are less strong in maths or have that maths anxiety.
Yeah.
And how does that come into play, both for the students, but also for teachers?
Yeah, and maths anxiety is quite interesting. If you are on X these days, there's some conversations happening about maths anxiety on there at the moment, but it's a real thing. There's research behind it. If you're interested in reading up about maths anxiety, Professor Thomas Hunt is the person to look for. He's done quite a lot of research on it, and he's shown that many children and adults have this feeling of anxiety if they're given a mathematical problem. And actually, what he says is pretty much most adults at some point in their lives would have felt like that trying to solve a maths problem, particularly if you're in an examination situation or something like that. But some people feel like it every time they're given a maths problem to solve. And in actual fact, what's interesting is girls and women are more likely to have maths anxiety than boys and men, which is also an interesting component because that plays quite a lot into physics. If we think about Actually, if I talk about the data, actually, because girls underperform in maths and physics compared to boys, which is quite unusual because in most other subjects it's the other way round. So in English, for example, they outperform boys quite highly. So it's a big difference, and part of that is this element of maths anxiety, I think. So yeah, it's definitely something to consider. When it comes to teachers, if you are not particularly confident in your mathematics, that can come across when you're teaching it to students. And actually, sometimes teachers can say in passing, "Oh, I found maths difficult," or "Maths is really hard," or something like that. And that can make students more anxious because if they see you as the expert struggling with it, they're kind of thinking, "Well, me as the person who's learning from you, how can I possibly learn and understand?" So how, even if we do struggle with maths ourselves or have maths anxiety ourselves, making sure we don't show that to the students, I think is really important, and being confident. And that may mean that we need to practice our mathematical skills, maybe go through some of those problems before we go into the lesson, make sure we're sure with what we're doing and the process that we're going through when we're with the students in the classroom, I think.
Yeah, because it's amazing how quickly students can pick that up from their teachers. They can bring that in with them from parents, from siblings, anywhere where maths has been conveyed as a scary thing. They can really absorb themselves
And
and try
actually,
to
it's
counter
interesting you
that.
mentioned family there because actually that has a huge impact. That kind of like, well, of course you struggle with maths because I couldn't do it when I was at school either. Yeah, so that for the family impact
Yeah,
is huge, actually.
yeah. So where I want to talk about the impact that you can have by emphasizing maths and science. Where are the big areas that lose marks in exams? Where are the places that you feel like you can really move that needle?
Well, firstly, what will make a huge impact in physics is obviously the ability to manipulate equations. So that's, rearrange the equations or input data into the equations. That can have a huge impact in physics because a large proportion of the maths
Mhm.
in physics is equations based. There are some equations in chemistry and in biology as well, of course. So that's a key skill. And actually, it's really important to ask students to substitute before they rearrange the equation because
Yeah.
if they substitute the values incorrectly and rearrange incorrectly, they can at least pick up marks for substituting correctly. Whereas if they rearrange incorrectly at the start, that's it. They're going to
And
lose
it
all
can
of the
be
marks.
so much easier for them to visualize what they need to rearrange for after they've already done that easier process of one-to-one substituting things in. Their unknown becomes a lot clearer for
Absolutely,
the next
because you're
step.
basically left with one, you've got all these numbers and a letter, and they can really equate that to their, talking about linking back to maths again. They're so
Yeah.
used to in maths having all of these numbers and then the X somewhere in there, and they've got to try and find out the value for X. So if they've substituted in those values and they've just got A left for acceleration, it's much easier for them to understand what they need to do next. So yeah, absolutely, that makes a huge difference. I think graphing is another big area. So that crosses all three sciences. So students struggle to plot on the graphs. They struggle with lines of best fit. They also struggle to interpret. And this is where some of the command words come in as well. So the difference between describe the graph and what's happening and
Mhm.
explain the graph
Yeah.
and use your science to have an explanation. And that particularly comes up in topics like rates of reaction or enzymes in biology, where they really struggle with that. And then the higher level graphing skills, things like finding the gradient, or even the more complex drawing a tangent to the line and finding the
Yeah.
gradient of that. These are things students really struggle with. So graphing is another big area. If you can look at that, I think that will make a big difference. So those two together, you can pick
Mhm.
up a huge number of marks, I think. And then it's things like converting units. That's another big issue that comes up, and knowing which unit is most appropriate for the equation. So knowing, for example, that if the question gives it in terawatts, you need to convert to watts. If you're doing a titration calculation, if it's in centimeter cubed, you need to convert to decimeter cubed. Understanding not only how to do the conversion, but when it's appropriate to do the conversion as well. For the higher students, things like standard form, students really struggle. And what's interesting for us as science teachers is we'll often be trying to get them to do standard form with their calculators. But in maths, they have to be able to do it longhand. They've got to be able to do it with and without a calculator. And in some instances, it might be easier for us to do it longhand without the calculator for them to actually get the marks on the paper rather than putting all the numbers incorrect and doing the calculation
Definitely
correct.
seen students really struggle with standard form on calculators, knowing how to input it, knowing how to read it, whereas they get so used to seeing that written out longhand, and they have to
Yeah.
practice doing that longhand for maths exams, that it can, yeah, feel more familiar for them.
Yes, and you know, us understanding how to do that as teachers can make a
Mm.
huge difference as well. And I think that's where the new Educate resources are really useful, because they're not useful just for students. They show the process for the teacher as well, so the teacher can go away and model that too.
Yeah, absolutely. Karen's mentioned the new study guides that you've helped us produce. So we've got a new study guide for each of the 24 math skills that are outlined for GCSE. And those are being published this week. And I'm hoping a little bit later I can give you a little bit of a show of what they look like. And it's just an opportunity that we break down those skills quite granularly with great examples, worked examples and practice problems that you can, attach to your quizzes and help students just a little bit extra with those really specific areas to make a difference.
And I think it's particularly pertinent with multi-step calculations as well. So things like titrations, or in physics sometimes where they link equations together. So they'll link potentially gravitational potential energy calculation and kinetic energy calculations in a multi-step calculation. So that those kind of multi-step calculations are also a problem for students too. I'd say that would be the final area. But if you focus on really getting the equations right, really getting the graphs right as a first step, that can make a huge difference to the marks, I think.
Great. And we've talked a little bit about the jumping from the maths context into the science context. Can you talk a little bit about how you can collaborate between departments and how addressing maths for science might have some similarities with other cross-curricular things like literacy and numeracy, where you also need some interdepartmental support?
Yeah, I think what people often forget is if you get in a conversation with your maths team about maths and science and maths, you end up in arguments about lines of best fit on graphs quite often. Because the word line in maths actually means straight. So if you
Mm.
say line, it's got to be straight, and that's why students get confused and teachers get confused. But we know a line of best fit doesn't need to be straight in science. And you end up in that spiral conversation about that. And actually, you need to be talking much deeper than that. If you can provide your maths department with the statements from the back of the specification, these are the math skills that we need to cover in science, and that's a good starting point. And actually, if you do an audit within your own science department about how confident teachers are at teaching each of those, so they might be really confident doing them themselves, but actually teaching a student how to do those skills, they may not be as confident with. There's something called pedagogical content knowledge that comes in at this point here. So, pedagogical knowledge is knowing how to teach something. Content knowledge is knowing the thing you're going to teach, so physics, for example, or, rearranging an equation. But pedagogical content knowledge is knowing the best way to teach that piece of knowledge. And because as science teachers, we're not maths teachers, we don't necessarily know the best way to teach children how to rearrange an equation. So if we can talk to our maths colleagues about that, that makes a huge difference. So once you've gone through and done the audit, teaching how to add together two numbers in standard form. What's the best way of doing that? Your maths teachers will have strategies to do that. They'll have what they call manipulatives. So they'll have visuals, or they'll have, actual physical things that can help students with particular mathematical problems. They know where to go if a student doesn't understand it the first way that you teach it. They'll have a follow-up method, which we don't have because we're not experts in maths teaching. So it's about talking to them about that. That's the first thing. And the second thing is by providing them with science examples. Maths teachers are forever making up questions. If we can give them science questions to use those mathematical skills with, students can see their maths teachers doing science and showing it's exactly the same. And that helps that transfer of knowledge and understanding for the student, but it helps us as well. And it helps the maths team too. Because they're always looking for examples. So I think that's really powerful. And we need to include subjects like geography, in those discussions about graphing in particular. They do some quite complex graphs in geography, actually, and really get them involved in the conversation too. So make sure we're not spiraling down, oh, we need to do it like this in our subject, but you need to do it like that. But more about those commonalities. How are they similar? And how can we draw across the similar strategies to make sure
Yeah.
that we're covering it in a simple and easy way for students to understand?
Yeah, so surface level, what might be the terminology changes that you should be aware of and mention to students so that they're aware of, but then a little bit deeper level, what is that pedagogical content knowledge that your maths department can teach you in order to help improve your teaching of the maths in science.
Definitely.
Yeah.
Yeah.
And I love the idea of science examples in maths. I know we worked recently with the Royal Meteorological Society about some climate change resources, and they suggested that it can be cross-curricular. If you need an example of reading a graph in science or in maths, use some climate data, make it a familiar thing so that it becomes less and less daunting and unfamiliar as they go.
And less abstract as well. And you know, something like climate change is huge. You know, students are worried about it, and they can see how maths, this is how maths and science is important, and how maths and science collaborate as well to show information in a way that's easy for people to understand. And that's the point of it. Yeah.
Yeah. Excellent. We've talked a little bit about different terminology and things. How useful is it to explicitly signpost when you're teaching math skills to students?
I think it's actually very important. I think because if you're hoping that they can pull knowledge and understanding from maths into science, if you're signposting that to the students and saying, right, okay, today we're going to be doing some algebra, or we're going to be rearranging some equations, and we're going to be inputting data into equations. Now, it's interesting, I said rearranging equations there because we often use that language when we're talking in science. But actually in maths, what they would say is change the subject of an equation. So you can still say rearrange. So we're going to rearrange the equation to change the subject of the equation. Or you could say change the subject of the equation to acceleration. And using that language, that same language, helps with that crossover as well. So yeah, really important, I think.
Some really quite specific and thoughtful language changes, which probably take some really conscious effort at first until they become habit and routine. And it might take looking at how you lay out a lesson and building them in your script, your regular patter regularly for a while until it becomes second nature. Yeah.
Yeah, and I think there's a key word there was habit. It's really difficult to change the way we teach because you do drop back into doing what you've always done. So yeah, changing habits is quite key.
Yeah. And do you have any tips about what works best, like some specific practical tips when addressing maths and science?
I would say there are some really useful strategies that are used in mathematics that we can use, which are teaching strategies as opposed to, you know, very specific pedagogical strategies for particular pieces of content. So one of the really useful ones that you can use is something called fading. And this, if you're interested in it, there's a blog post on the Education Endowment Fund by Bob Pritchard, and he explains how we can use fading effectively to support students, particularly with multi-step calculations. So fading is where you first of all would model a calculation. So it could be a titration, if you take a titration calculation. So you would model how to answer that titration calculation. You do the full calculation. The next time you do part of the calculation, so that you'd start at the top, move down to a particular point, and then you say, right, you finish this off now. You continue the rest of the calculation using my original one as a model. And then you do a different calculation again, but this time the students would complete it independently using the two previous models. So it's fading, and you're fading from the bottom. And you can do this with simple calculations like a distance, speed, distance, time calculation if it involves a rearrange of the equation. And that will support students with the knowledge and understanding. And it's almost like a strategy they use in maths called I do, we do, you do. And so you know, I'm going to model it first. We're going to do it together, but I'm going to model the first bit. You're going to finish it off. And then you're going to do some independent practice using those as a model to start off with. So fading is a really useful strategy to use. The second one I think is really useful is called think aloud. And this is an unusual strategy because it works really well in maths and it works really well in English and with reading. And it's very unusual for a strategy to work in both those subject areas. So it's very good for exam analysis as well. So if you're getting students to understand how to answer an examination question effectively, this works well too. So think aloud is basically you talking through the problem solving that you are going through as you do it in real time. So you've got an exam question in front of you. Most students genuinely believe that we just know the knowledge off the top of our head. They don't realize that in order to answer a question, we are problem solving. So what we do is you would read through the question and you'd be annotating as you went along and talking about the metacognitive process you're going through as you answer the question. So, as you see the command word, saying what the command word means, and then, going through, and if you highlight some particular terms in there that you might see, if you see, an explanation or a key science word or something like that, talking about that. And then, so for example, in a titration, you might say, oh, I can see this value is in centimetre cubed. I know I'm going to have to convert this to decimetre cubed. And in order to do that, I need to do this. So that process that you're going through, and then as you finished reading the question, then start answering the question the way you would answer it. So not following the mark scheme, answering it the way you would answer it if you were sat in an exam question, and talking through what you're thinking as you do it. And it works really well under a visualizer, and students can then mirror that process in a second question. They can do a similar process to what you've done. Now, Think Aloud also works if student talks to student as well. If a student explains what they're doing as they go through a question, that's really powerful too. So Think Aloud, either the teacher explaining or the child explaining, works really well.
Making them have an audience to their thought process means they don't let themselves just skip
Yeah.
to trying to get the solution.
Yeah.
They have to
And
go through
and that they
problem solving step.
understand that we don't know the answer. We have to work it out.
Yeah. And I can see fading being particularly useful, especially for those multi-step problems, where you're maybe needing to, at different points, use two different equations or find value before you can then finish an equation. I see that being really very useful for that kind of more detailed calculation.
Or if there's actually unit conversion, makes a huge difference for unit conversion. Yeah.
And what works well? What are some good approaches when it comes to homework for this kind of thing?
I would say if you're doing homework, getting them to practice, I think, is key. Because the reason often students do well in maths is because they get it modelled and they get lots of practice. And the problem we have in science is we have so much content to get through. It's very difficult for us to give the levels of practice with maths in science as they would do in maths. In fact, if you talk to a maths teacher, they're quite shocked by how little practice we do with the students with individual equations and different pieces of maths. So I would say if you can really clearly model how to do something in a lesson, get them to do some individual practice, and then use the homework time for practice, that will make a big difference. And also, if you can give students the opportunity to re-look at how to do a problem. So if they, if it's a couple of weeks later and you're doing a little bit of retrieval practice, doing that in the homework and saying, right, go back and do some more examples of this thing that we did, say, 3 weeks ago. And if you need help on it, here's somewhere you can go where there's a modelled approach of how to do it. I think that's really useful. So I think using homework, because one of the mistakes we make in science quite often is we do the application for the homework. We do get them to do the difficult bit for the homework. And actually what it just needs to be is practice, 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 because we haven't got time to do that in lessons.
Yeah. And one of those study guides that we mentioned earlier, I'm going to do a real quick share here so we can show what kind of support that can offer. And I liked your suggestion. Can I just double check you can see that?
Yes, yeah.
So we have some revision resources here, and great, in your maths for science, they're all broken down as they are in the list outlined by DB. And you can find all the different topics here. Each one has a study guide and they're broken down into some quite granular steps and skills. So just as an example, we've got, as we talked about earlier, using a standard form and the calculations involving standard form. And for students, I'm going to hope that I haven't timed out here. Check. Oh no. Good time for this to freeze, isn't it?
It's because it's trying to think about too many things at the same time.
Yeah. Anyway, we have both these revision guides, which allow you to really have students slow down, take a look at some of those worked examples, and understand the steps involved, and then apply it to questions, because we also have within our question bank loads of math for science questions broken down by those skills. And it can be a really nice thing to focus on their own, But because you can really flexibly tailor a quiz depending on what topics you want to cover, you can throw in some of those standard form questions alongside that topic in physics that you're doing right now. So you can just add in that practice when you know that there's going to be one of those skills coming up that they might struggle with. Let me see. Yeah, here we go. Lovely. They can read them line at a time if they want, or you can show all and they can look through. These are also available to students for independent study. So it's a really great way to give them some extra support that they can access whenever they need. And when they're planning what their revision needs to be and what they want to focus on, this is available for them. They can go and look at a study guide. When they get to an end of it, we automatically offer them the option of taking a 10-question quiz. So they can, within their own revision, build in that study and then assess loop on their own to try and improve. So it's a great option that doesn't add extra workload for teachers.
Yeah, and what you'll notice is here when you get to these pieces here, you can see that's generic. So it's very much focusing on the math skill itself. It's not put it into a context here. It's like, how do we do it just with focusing on the maths and helping them make that link between maths and science as well.
Yeah. And then there'll also be examples there that have that science context so they can start linking it back. But it works sort of from the generic as well as with context.
Yeah, and that's quite unusual for resources. I think a lot of them put them into context and don't deal with the skill separately, which I think is important.
Yeah. And there's lots of practices and lots of examples here, so there's plenty of opportunities to go through those. And then with the question bank as well, just building in more of that practice that you said, like in maths, they get that repetition and that drilling more frequently.
Yeah, definitely.
Well, this has been really, really interesting. Thank you so much for sharing your knowledge. Is there anything else you think you would like to pass on about maths for science?
This might be controversial, but
Good.
formula triangles.
Oh.
It's probably worth mentioning formula triangles. I would say some people are very fond of formula triangles. I would say avoid them if possible, because when we talk about something like fading or think aloud, they are basically forms of scaffolding. And you should be able to remove scaffolding over time, and students should be able to independently be able to do that skill. If you remove formula triangles over time, it doesn't mean students are able to rearrange an equation without the formula triangle. So just have second thoughts if you're using formula triangles and do something different instead.
I know I've had reports of students struggling to use formula triangles because they can't write it on their own because they haven't gone through the work of memorizing what the triangle actually is. So they can use it when given to them, but yeah, on their own,
Yeah, and
they
they
don't
don't
have that
understand
knowledge.
how it's formed. Yeah, so just be wary of that. I would say that would be my parting note.
Yeah. Excellent. I'm just gonna hand over to Alison to see if we have any questions for either Karen or myself.
That's great. Thank you so much to Karen and Constance. Really, really interesting conversation. I'm sure we've all learned a lot and it's given us lots of ideas for ways to support maths and science. So the Q&A function, you'll see it at the bottom of your screen. I'm going to have a look at some of the questions that you submitted. If you still are thinking one, please don't hesitate. I've got my eyes on it, so I'll see it as it comes in. And we'll start to go through those. So, my students struggle with reading and creating graphs. What would your advice be? So that's one for Karen.
Oh, well, I'm going to shamelessly plug a book of mine called Grappling with Graphs. And this book has got a whole series of CPD at the front that explains how to teach graphs to students. And then afterwards has a whole series of activities which you can give to students that breaks graphing down into the granular. So there's things that you can use to plot and things that you can use to interpret. And it covers all of those graphing skills. So shameless plug of Grappling with Graphs.
It is really, really full of useful techniques. I thought that I had my copy on the windowsill here, but it's actually on my bookshelf at work. So I can't hold it up for
I
you.
thought I had mine as well, but it's not here. So
it's really, really useful, Gem.
Amazing, thank you. We've got another question. If you were teaching them how to produce the formula triangles as part of Think Aloud and metacognition, is this not okay?
Well, again, as I said, because think about it, if you remove the formula triangle over time, which is what you're supposed to do with a piece of scaffolding, the students wouldn't be able to rearrange the equation. It's much better to teach them how to rearrange an equation properly, because that would be more helpful. Remember, they're going to get given the formula sheets in the exam. They don't need to learn the equations. What they need to do is learn how to rearrange the equations that are given on the formula sheet. So spending time teaching them how to use the formula sheet properly and rearrange the equations will be much more beneficial than using formula triangles. As I said, controversial, because I know some people will disagree with me, but I very strongly feel that that's the case.
One of those Marmite topics, isn't it?
Yes, it's definitely a Marmite topic, yes.
That's great, thank you. So I've got another one. I'm making a maths cheat sheet / glossary that students can put in their physics books for when they're doing homework. Is this a good idea, and what information would you include?
That's interesting. I would ask the same question. What information's going on your cheat sheet? That's interesting. I think cheat sheets like that are really useful, again, as a form of scaffolding. So what you need to think about is make sure you're referring to them on a regular basis. What often happens with cheat sheets is they get stuck into a front of the book and they're never seen again. So do make sure they're being referred to on a regular basis. Think about how is that being embedded into the pedagogy that's going on in the classroom? How is it being used for teaching and learning? And then how is it being removed over time? Because if students don't have that cheat sheet in the exam, which they won't, it's how have I got the students to a stage where it's habit, whatever that sheet is helping them with, it's a habit now. So it could be something like how to convert centimeter cubed to cubed, how to convert watts to tera or terawatts to watts, for example, how to add or how to multiply. Actually, standard form is what comes up most often, is multiplying standard form or dividing standard form, things like that. The hints and tips that you'd want them to be able to do automatically after a period of time, but it's got to be referred to, because if it's not referred to and not used, then it's a waste of paper.
Amazing, thank you. We've got a question about formula triangles. So I get them to make the formula triangle from the formula sheet. And as a dyslexic learner, I find the visual helpful for my processing of what is being asked to do, to stop me getting confused and guide the thought process. Can I teach both and let them have the option for what works for them?
I mean, you could do. I mean, I'd just be honest. I used to use formula triangles. I was a formula triangle advocate. And it was only when somebody pointed out that it's a piece of scaffolding that I realized if I removed that scaffolding, they wouldn't be able to do it. I completely understand the visuals. I used to do pictures even when I was doing the mole triangle, for example. I had images in the mole triangle to help them with that. But I'd say they've got to be able to, in order that process of turning an equation into a triangle is actually cognitively quite difficult, particularly if you come across something like kinetic energy, where it's a very, very difficult to do that. It is easy relatively to rearrange an equation. The process is not that difficult, and I would suggest that maybe sometimes we think turning it into a triangle is easier than rearranging, and I'd suggest that they're probably equivalent in terms of difficulty. So that, I have changed my opinion over time, but as I said, Marmite topic. So
That's great, thank you so much. Any other questions, like we said, please pop them in. I've got one for Constance. What key stages does Educate cover for science?
Yeah. Most people know us for secondary, Key Stage 3 and GCSE. We do also do science at primary, and I am particularly excited. I've been spending most of my time the last few months working on A level. So we will be launching A level science for AQA and OCR in January this year. So that's something to keep your eyes out for. It's been a challenging one to work on and really exciting.
I agree. Yeah, it's really exciting news. It's been such a popular request and a lot of work, as I'm sure you can all imagine, a huge project as well. So we're really looking forward to that coming out in January. Great. So unless there are any other questions, that brings us to the end of the webinar. We'll send a follow-up email in a few days' time to everyone who registered. So if you want to go over and revisit these top tips, you can easily do that. Thanks so much to everyone here who took time out of their day to attend this webinar. We really, really appreciate it. And thank you, of course, to Constance and to Karen. Karen, where can people follow you on social media for all things math, science, etc.?
I'm on LinkedIn. If you just search for Karen Collins, there are a lot of Karen Collins on LinkedIn, but I'm sure you'll find me there. And I am on X as KCO Science.
And it's also worth following Karen. She's got lots of insights when it comes to practical work in science, in addition to Maths for Science. So there's loads more useful nuggets there.
Thank you.
Absolutely. So yes, thank you so much for coming. Thank you so much to Constance and Karen. It's been a really fascinating conversation. I think it's given us a lot to think about. To all of you listening, please do get in touch, support@educate.co.uk if there's anything at all that we can help you with. If you'd like any more information about how Educate can support you or your students, we're very happy to provide a demo of any of the features that we've shown. Yeah, just let us know. You'll get a prompt human response if you email us at support@educate.co.uk. But just taking one quick glance at the Q&A, no other last minute questions have come through. So I'll say thanks again to everyone for attending and to Constance and Karen, and goodbye for now.
Thanks,
Great.
Alison. Bye.